Hi children, how are you? I am fine. I hope that you are also fine. Today we have to discuss about a 10th class maths chapter number 1 real numbers. Already you have to learn in your previous class natural number, whole number, integers, rational number, irrational number and so on. Now what is a natural number? Natural numbers. Natural number. The numbers 1, 2, 3, 4 are using for counting purpose are called a natural numbers. It is denoted by n. Natural numbers is denoted by n. N equal to what is that? 1, 2, 3, 4 and so on. Next, whole numbers. What is the whole numbers? The natural number together with 0 is called a whole numbers. Together with 0 is called a whole number. 0, 1, 2, 3, 4 and so on. These are whole numbers. Whole numbers is denoted by, it is denoted by W. Next, integers. Integers. Integers is denoted. Integers mean the system of number which consists of negative natural number, 0 and positive natural number is called a integers. That is, and so on, -3, -2, -1, 0, 1, 2, 3 and so on. It is integers is denoted by I or J. I or J. Next, rational number. Rational number. Rational numbers. Rational numbers. A number which can be expressed in the form of P by Q, where P and Q are integer and Q not equal 0. It is denoted by Q. It is denoted by Q. It is a rational number in the form of P by Q, and Q not equal 0. P and Q are integer. P and Q belongs to J. Rational number. Example, -2 by 3, 1 by 2, 3 by 4, 0, -3, -8 and so on. This is like this. It is an example of rational number. Next, irrational numbers. Irrational numbers. Irrational numbers, a number which cannot be expressed in the form of P by Q, where Q not equal 0 and P and Q are integers, is called an irrational number. It is represented by S. It is represented by S. S is equal to not equal to P by Q and Q not equal to 0. P Q belongs to J. Understood? Example, √2, √5, √7, √11 and so on. These like this. These are the example of irrational number. Now what is a real number? Real number means a rational number and irrational number together is called a real number. Together is called a real number. Real number is denoted by real numbers is denoted by R. Real numbers is denoted by R. What is the definition? A rational number and irrational number together is called a real numbers. Okay. Now R equal to, what is R equal to? Q union S. R equal to Q union S. Representation of, diagrammatic representation of number system. Okay. Diagrammatic representation of number system. Diagrammatic representation of number system. First you have to take whole numbers. First natural numbers. N. It is n. Next along with 0 including, it is a whole numbers. Next how to take another way. It is a integers or z. Next another circle also take like this. It is a rational numbers. Now separately you have to, like this you have to take, this is called a irrational number. Yes, rational number, integers, whole number, natural number. And totally this total irrational number and rational number together is called a real numbers. Together is called a real numbers. Understood? What is n? N is the set of natural number, W means the set of whole number, Z means the set of integer, and Q means the set of integers. S means set of and irrational numbers. Irrational number, it is a irrational number. R is called a real numbers. Okay. Now fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Any composite number can be expressed as a product of primes unequally. That is called a fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Now, for suppose if A is any composite number, then A equal to P1 power n into P2 power n into P3 power n and so on, where P1, P2, P3 and so on are prime numbers. And L, M and so on are whole numbers. Understood? Is a fundamental theorem of arithmetic. Fundamental theorem of arithmetic means any composite number can be expressed as a product of primes unequally. Okay, right. Now For example 420. Write into the prime factors. 420 factors first find out. 420 factors. 210. Next 2. 2 ones are 2 fives are. Next 2. 2 how many times? Next 5 you have to take. 5 twos are 5 ones are. Next 3. 3 sevens are. 420 is equal to 2 square into 5 into 3 into 7. So you observe that here 2, 5, 3, 7 are the prime numbers, and powers here 2 power is L equal to 2, here M is equal to 1, N is equal to 1, and also add the number, some any number also like this. It is powers is a whole numbers, and P1, P2, P3 are the prime numbers. Are you understood? Okay, it is a fundamental theorem of arithmetic. Now you have to calculate HF and LCM by using with the fundamental theorem. Okay, fundamental theorem of arithmetic using it. Now prime factors. First so problem, find HF and LCM of 72 and 108. Now we have to find out 72 and 108. Listen, first write the problem. Solution very simple. First write into the facts of prime factors. 72 is equal to, what is the facts of 72? 72 factors calculate. 2 how many times? 2 3s are 2 6 are. Next 2 1s are 2 8s are. 2 9s are. 3 3s are. So what is the factors? 2 cube into 3 square. Next 108. 108 factors find out. 108 equal to 2. 254s are 2. 27s are 3. 9s are 3. 3s are. What I mean, it is 2 square into 3 cube. 2 square into 3 cube. Now you have to calculate HF. HF finding before you observe that the numbers. Here what is the first write into the common base. Here 2 is the base, here 2 is the base. Common base should write first. First what is the first step? Write the common base. Here base 3, here also base 3. Common base is 3. First write the base. After you observe that the common base, which is the least number, least power of the base, power of the number, least power base. Okay, so least number mean here 2, here 3. 2 cube, it is a 2 square. So both you observe that it is a 2 is a less number, 3 is a big number. Powers, less powers. Less power mean here 2. Both the numbers you observe that it is a 3 cube, it is a 3 square. It is a 2, it is a 3. 3 is a big number, it is 2 is a least number. So right, take 2, least number. Now 2 square mean how much? 4. 3 square mean 9. 9 4s are how much? 36. 36 is the HF of 72. Therefore 36 is the HF of 72. Therefore HF of 72 and 108 is 36. Now how can you finding LCM? LCM very simple. LCM how can, here LCM is equal to, first write the all bases. All bases only for 2 and 3 only there. 2 and 2, 3. All bases first write into the all bases. Next you observe that is so 2 square, it is 2 square, which is the highest power of the base. Highest powers, and here in 2 square it is 2 cube. 2 cube is the highest power, so 2 cube. Next you observe that 3 square 3 cube, which is the highest power? 3 cube. So 3 cube. Like this, 2 cube mean 8, 2, 3 cube mean 27. Is equal to, right, 216. What is the answer? 216. So it is a LCM. Very easy way. LCM and HCF by using with fundamental theorem of arithmetic. Now you have to finding next another definition also there. So next, Euclid division lemma, very important definition. Euclid division lemma. Euclid's studies here. Euclid's division lemma. Euclid division lemma. Euclid division lemma is a very important in first exercise. Okay, what is the Euclid division lemma? Given positive integers a and b, given positive integers a and b, they resist a whole number, whole numbers q and r, satisfying a is equal to bq plus r, where 0 less than or less than b. This is called a Euclid division lemma. Okay. Now using with Euclid division lemma, you have to calculate HCF. Okay. For example, find the HCF of 72 and 108. Okay, the same number. Before example, try yourself by using with Euclid division. That is a fundamental theorem of arithmetic using with that. Now calculate HCF, but it is a HCF of 72 and 100 by using with the Euclid division lemma. How can you find it? Very simple. You observe that given numbers, once observe which is the largest number. Largest number is 108. Smallest number is 72. Here, largest number is let 108. Largest number is equal to A equal to 108. Smallest number B equal to 72. Okay, given numbers 72 and 108. Largest number, let largest number B A is equal to 108. Then the smallest number, therefore B is equal to how much? 72. B is equal to 72. By Euclid division lemma, by Euclid's division lemma, A is equal to, what is the formula? BQ plus R, where 0 less than or less than B. Therefore, in the form of, you have to write down by Euclid division lemma, calculate next step. Therefore, 108 is equal to how many times? 1 into 72 into 1 plus 36. Total 108. Again, you have to take this number, you have to follow like this. 72 equal to, again write it as the factors. Here, we observe that here A is equal to 108, Here B is equal to 72 and Q is equal to how much? 1 and remainder R equal to 36. Here R is a remainder. Quotient is equal to 1. Next 72 is equal to this number you have to write and the remainder with the remainder you have to divide by. 72 is divided by 36. 36 how many times? 36 2s are 72 plus remainder is 0. Here Q is equal to 2 and R equal to 0. So this is the required solution. Therefore HCF of 108 and 72 is 36. I already previous example already you have to finding already by using fundamental theorem of arithmetic. This method also I have to calculate. Now same answer is given. So HCF of 108 and 72 is 36. Okay, understood? Now some general sums now I have to solve it. Try yourself. I have to give you some example, some sums. So try yourself. Next, find HCF by the method of using with Euclid division lemma. Find HCF. First one 900 and 270. Try yourself. Second one 196 and 38220. Third one 1651 and 203. Okay, do the sums. It is a homework. 900 and 270, 196 like this. These three sums try yourself by using with the Euclid division lemma. Now in exercise number 1.1, the first sum, second sum I have to explain. Try. What is the first sum? Second sum in the exercise number 1.1. First sum. Exercise number 1, first sum and second sum like this. Problem. Use Euclid division lemma to show that any positive odd integer either integer is of the form 6 cube or 6 cube plus 1 or 6 cube plus 3 or 6 cube plus 5 where q is some integer where q is some integer. Duster. Use Euclid division lemma to show that any positive odd integer is of the form 6q plus 1, 6q plus 3, 6q plus 5 where q is some integer. Simple solution was observed. Let a and b are any positive integers and b is equal to 6. Here already given 6. Here for suppose sometime here given a 4. You have to take b value 4. Here this is a 6. So like this. So that's why I have to take b is equal to 6. By Euclid division lemma, Euclid division lemma, A is equal to BQ plus R where 0 less than or less than P. So A is equal to 6Q plus R. Here 0 less than or less than 6. Therefore, that is R equal to, what is the remainder? That is R equal to, what is the satisfied? 0, 1, 2, 3, 4, 5. These numbers are satisfied like this. Okay, if R equal to 0, then A is equal to 6Q plus 0 is equal to 6Q. 6Q is an even number. 6Q is an even number. Next, if R equal to 1, then A is equal to 6Q plus 1. So 2n plus 1, 2 is a factor, 2n plus 1 is a odd number, odd integer. 6Q plus 1. If R equal to how much? 2, then A is equal to 6Q plus 2. Already clear, 2 is a factor, so it is an even number. So even. If R equal to 3, then A is equal to 6Q plus 3. We observe that 3 is a factor, then 6Q plus 3 is a factor, so definitely it is a odd integer. Next, if R equal to 4, then A is equal to 6Q plus 4. Clearly 2 is a factor, so it is a even. If R equal to 5, then A is equal to 6Q plus 5. Here it is a odd number, clearly odd number. So 5 is an odd number, so totally odd numbers. So like this. What do you observe that? Therefore, if A is any positive, if A is even positive integer, even positive integers either in the form of in the form of 6Q plus 2 or 6Q plus 4, where Q is some integer. Okay, next first and another step also there. If any odd positive integers either in the either in the form of 6 cube plus 1 or 6 cube plus 3 or 6 cube plus 1. Where q is some integer. Okay, it is the required answer. Understood? So same method also, another sum also there. Once observe. Understood? Two categories, 6 cube plus 2, 6 cube plus 4, all even numbers. It is a 6 cube plus 1, 6 cube plus 3, 6 cube plus 3 are the odd positive integers. Next, another sum also there. Number 2.